Dear colleagues, I'm glad to present our study, an approach and a software tool for automatic source code generation driven by business rules. It was prepared by me, Andrii Kopp, and my colleague, Dmytro Orlovskyi. We represent together the Department of Software Engineering and Management Intelligent Technology of National Technical University, Kharkiv Polytechnic Institute. Let's start with the motivation of our research. It's well known that time between specifications capturing and the product delivery is critical for the software engineering and the customers. So the source code generation could really increase the software development process by shortening the time between requirements gathering and delivery using automatic programming and other low-code solutions. The main idea of automatic programming is to tell the computer what to do rather than how to do the task. This is why the automatic programming should be supported by some definitive high-level language that is closer to a natural language more than to the programming language. This is why this paper aims at automatic source code generation from natural language statements given as business rules to facilitate the software development process by bridging a gap between business analysis and engineering. We attempt to use the semantic of business vocabulary and rules standard by the Object Management Group, or simply SBVR standard, to provide a unified solution that can be integrated with other software development utilities. We want to improve the previously proposed approach, which was based on translation of fact business rules into SQL data definition language scripts by using the model-driven development paradigm when business rules are given as subject domain descriptions to build an abstract model with multiple possible implementations. First of all, we need to translate the given SBVR business rules into the triplestore model. Each of the given business rules is translated to the lowercase string, which then is tokenized. Mark of words with part of speech tags is performed on the next step, and then we check the words part of speech. If it's the none, we append this word as the subject, and if the word is a verb, then we consider is as the predicate, and if the word is a noun after standing after the predicate, we append such word to the object, or otherwise we just skip such word. Then we just need to separate the words in subjects and objects by the underscore character to avoid the confusing situations. And finally, we can get the triple store from the business rules given on input, and we can retrieve triples. We can use them to build object-oriented entity relationship or any other data models. Then we can use this triple store model to build actually the data model. To restrict the syntax of business rules, we propose to consider only several verbs according to their purpose. Has, which will mean that unnecessary attributes that can actually hold the null or missing values. Owns, which means that mandatory attributes are described and they cannot hold null or missing values. And includes verb that should display the relationship between certain entities. Having this data model obtained using proposed algorithm, we can build different software implementations of such models, like SQL scripts for database creation, programming language classes and objects, and other software engineering artifacts. Then, having the data model, we need to get the proper data types, and we propose here to use the Spider data set maintained by Yale students and personnel. This data set includes 200 or about 200 databases with multiple tables that cover 138 different domains, different industries. Having such a large data set, we can apply the association rules approach to suggest the most suitable data type based on the attribute names only. After the data types are suggested using the associative rules approach, we need to adjust them because the YEL dataset includes SQL databases, and we need to generalize obtained data types so we can map these generic data types further for various software development components which we can generate from the data model, like classes or structures, database scripts, blockchain smart contracts, or other source code that declares the data structures. So we propose the data types used in the most popular enterprise programming languages and SQL-based database management systems. Using the procedure, we check the suggested attribute and its data type. If it includes int, we consider it as the integer. If it contains the real, double, float, numeric, or decimal, we can give the generic floating point data type to such attribute. And if the type includes bool, we can consider it as the boolean. Otherwise, all attributes we propose to mark as the string attributes with further mapping into different text representation data types in proposed mapping for enterprise development technologies. The implementation of software components based on data model assumes that building the abstract data model from the business rules can be achieved to define entities or concepts, their attributes, and interrelationships. Therefore, data model can be based on business rules and data type association rules, which can be used to automatically generate almost any software component for which are only necessary rules on entity representation according to given syntax, rules on attribute representations, including mandatory attributes and not necessary attributes, also according to the required syntax, rules on relationship representation according to necessary syntax, and rules on attribute data type representation also according to the syntax of certain language in which we need to generate software artifacts. Finally, we have implemented the software solution using the proposed approach, and we use the Python programming language because of its relative simplicity, flexibility, and first of all, actually the rich collection of packages, including the packages that can help us work with the natural language processing and database operations. The general workflow of our Python's program includes 4 steps: produce the source code for entities, then produce the source code for attributes, then append the source code with restrictions for not null attributes, and then finally produce the source code for relationships. Let's take a look at the simple example. We have a relatively short set of SBVR business rules in a simple English language that describe a certain near to e-commerce domain of products, categories, and brands, and their respective attributes. Using our approach and the software solution, we first of all obtain the triple store model based on such business rules, and using the triple store model, we have successfully built the data model, including the unique attributes now and the relationships between the entities. On the next steps, we have obtained the suggested data types based on association rules, and we generated 2 kinds of software artifacts. The source code of SQL scripts that can be used to create a respective database, and the source code of Java beans or Java plain classes, which can be used to create client database applications for the database described using SQL scripts. We actually made also the static analysis of Java beans code that we generated using the Sonarlint tool for Eclipse IDE, and we have identified several issues like invalid class names, field names, method names, and usage of generic exceptions instead of specific ones. But besides these code conventions issues, the execution of generated Java beans have demonstrated successfully compiled classes. And we used the MySQL server to check the generated SQL database creation scripts, and we obtained the successfully created tables in the MySQL server database. Data manipulation SQL statements have demonstrated the integrity and consistency of created database tables when we tried to test foreign key constraints by adding the child row which refers to a record that doesn't exist. And we also tested null columns which have also demonstrated the successful and validity of constraints. To conclude, we can say that despite the detected limitations of the proposed approach and the software tool, generated SQL database creation scripts and Java bean classes are valid and they are correspond to the given business rules. Generated artifacts can be used in the information system software development project after minor tuning to, first of all, customize data types, and for the second, to meet the coding conventions used in some or another project. And this study encourages projects to move toward the intelligent software engineering practices that assume the usage of intelligence techniques in software engineering. The proposed approach and software based on natural language processing techniques assume that implementation of the intelligent source code generation system that is proposed to bridge the gap between software requirements and the design of the information systems data layer. And in future, the elaborated intelligent system may result in automatic source code generation environment, or at least plugin that can augment the traditional IDEs. Thank you very much for your attention.